everyone. During today's lesson, we are going to talk about statistical significance and errors. So there's actually two types of errors we can make when we do a hypothesis test and draw our conclusion. So we will be talking about those and how to reduce the risk of making those errors and kind of what they may look like in some real-world examples as well. So first off, statistical significance. What does it mean if we say the results of a hypothesis test are statistically significant? So the results of a study are called statistically significant if they are unlikely to happen by random chance, when the null hypothesis is true. And we say this because when we start every hypothesis test, we go in always assuming the null hypothesis is true. So if results are statistically significant, that means they're unlikely to happen by random chance. So that means we get a low p-value. Okay, so results are statistically significant when they're unlikely to happen by random chance, or in other words, we get a low p-value. Thus, results are statistically significant whenever they provide convincing evidence that, so let's think about this. If we have a low p-value, we do have convincing evidence to accept HA. So in other words, provide us convincing evidence that our alternative hypothesis is true. In other words, we can rule out random chance as an explanation for the unusual performance. So these results were significant enough to make us change our mind that, you know what, in conclusion, we're going with the alternative hypothesis here, and we no longer feel like the null hypothesis is true. So recall, what's a p-value? A p-value is how likely it is to get a test statistic at least as extreme as the observed value by random chance. So the smaller the p-value, or the closer the p-value is to 0, the stronger the evidence we have to support our alternative hypothesis. So significance level. Significance level is a predetermined level of evidence that is required to confidently rule out random chance as an explanation. So the most common significance level that is typically used is 5%. And that is what we've been using these last two chapters as our significance level to make our conclusions for our hypothesis test. Other common significance levels you'll see are 1% and 10%. So if 5% is the most common, why would we use 1% or 0.01 as a significance level? Well, we would use that when we'd want the evidence to be more convincing. Okay, so if we want the evidence to be more convincing, if we drop it from 5% to 1%, now it's becoming less likely that we accept the alternative hypothesis because we drop the significance level. So now conclusions would change for a p-value of 4% or 3%. So we use 0.01 as opposed to 5% when we want the evidence to be more convincing. Okay. Now, what about, I told you another common significance level was actually 10% or 0.1. And we'd use that when we don't need the evidence to be as convincing. Okay. So keep that in mind. So now, let's just pretend our p-value is 0.03. What conclusion would we make if our significance level, so keep in mind significance level is referred to, the symbol is alpha, okay? So for significance level, the symbol is alpha. So let's say our significance level is our usual, which is 5%. What conclusion will we make if our p-value was 0.03? So therefore our p-value of 0.03 is less than 0.05. Therefore we do support HA. However, what if our significance level dropped from 5% to 1%? So now our p-value of 0.03 is greater than 0.01, our significance level. Therefore, we do not support HA. Okay, so, you know, doctors, statisticians, they change. Significance levels change depending on which type of error could be worse in that scenario that you're given. Okay, if you're talking about the medical field and a certain medical test versus something else that you might be discussing, and a lot of the context of ours is sports, so therefore we just keep an even 5% because the errors are kind of equivalent in terms of which one is worse. But in some medical tests, it could be very different. So keep that in mind. So the first type of error we're going to talk about is what's called type 1 error. So which type of error you make is based off of, or which type of error, you could potentially make is based off of what your conclusion. So type 1 error is when you are supporting your alternate hypothesis when in fact your null hypothesis is true. So supporting HA when in fact your null hypothesis is actually true. Remember, when you're describing an error, you're describing a mistake that was made. So I like to kind of use the transition words when in fact to kind of transition, like I said this, however, this is actually true, or when in fact this is actually true. So you guys are familiar with a courtroom scenario. So in a courtroom, type 1 error is actually convicting an innocent person. So the jury wrongfully convicted an innocent person. So the jury decided that there is convincing evidence of guilt even though the defendant is really innocent. So here's a scenario, a different scenario for you to look at. Let's say our null hypothesis is Emily has the same ability to get an A on a stats test regardless of her grade on the previous test. And the alternate is that Emily has a greater ability to get an A on the stats test following an A test score than following a non-A test score. What would type 1 error be in this context? Remember, type 1 error is when you support HA. So concluding that Emily has a greater ability to get an A on a stats test following an A score, when in fact, her ability is the same regardless of her grade on the previous test. So let's write that out. Concluding Emily has a greater ability to get an A on a stats test following an A test score when in fact her ability to get an A on a stats test is the same regardless of her previous score. Or her previous test grade. So yes, they can be lengthy to write. We're not going to have you do a ton of these on your Chapter 3 test. You're going to have to describe type 1, and then you're going to learn in just a second the type 2 error one. So make sure they're good. Make sure they're quality. It's a one big quality statement for each type of error. Okay, and include all the necessary information. So how often are type 1 errors made? Well, your type 1 error rate equals your significance level. Okay, so if our type 1 error rate equals our significance level, what has been our significance level these last 2 chapters for hypothesis testing? It's been 5%. So currently it's about 5% of the time for us. Okay, so remember your type 1 error rate equals your significance level. Now, how can we avoid making type 1 errors? Well, remember, if our type 1 error rate equals the significance level, how do we lower that? Well, we simply lower the significance level. So currently in this class, we use 5% as our significance level, so maybe lowering it to 1%. Okay? So now let's talk about type 2 error. So with conclusions, we either support HA or we do not support HA. So type 2 error is when, in our conclusion, we do not support our alternative hypothesis, now remember, you're describing a mistake. So when we do not support HA, when in fact HA is true. So you're definitely going to need to reference this tonight on your homework. Okay? So in a courtroom trial, type 2 error would be failing to convict a guilty person. Since the jury has decided there was not convincing evidence of guilt, even though the defendant was actually guilty. So they are essentially letting a guilty person walk free on the streets. So also a difficult, not a good type of error. So I don't know how you can weigh in this case what's worse in a judicial trial, type 1 or type 2 error. We'll save that debate for later, but both are not good to make for the court system. So let's look at these hypotheses. They want us to describe the type 1 and type 2 errors for this pair. Your null hypothesis is that the PCP debate team has the same ability to win a debate following a win or a loss. And the alternate, they're trying to prove that the PCP debate team actually has a greater ability to win a debate following a win than a loss. So describe type 1 error in context, okay? So remember, type 1 error is when we support HA when HO is actually true. So concluding HA is true, concluding the PCP debate team has a greater ability to win a debate following a win when in fact their ability to win the debate is the same regardless of the outcome of the previous debate. Now, for type 2 error, remember, type 2 error is when we do not support HA when in fact it is actually true. So concluding the PCP debate team does not have a greater ability to win a debate following a win, when in fact they do have a greater ability to win following a win. So concluding the PCP debate team does not have a greater ability to win a debate following a win when in fact they actually do have a greater ability to win following a win. Okay? So go ahead and you can pause the video here and try writing the type 1 and type 2 errors for the following context with the 2019 Plymouth football team. And you can always restart the video when you're ready to check your answers. If not, you can stay along with me right here. So type 1 error is concluding the 2019 football team has a greater ability to win at home than on the road. When in fact their ability to win is the same regardless of where they play. Type 2 error would be concluding the 2019 Plymouth football team does not have a greater ability to win at home. When in fact they do have a greater ability to win at home. Okay? So, how can we avoid making type 2 errors? Okay? Well, we can actually look at a larger set of performances, or in other words, more data. Or going along with, if for avoid making type 1 errors, if we lower the significance level to avoid making type 1 errors, to avoid making type 2 errors, we could actually raise the significance level. Okay, so either one of those would work. So now, just to kind of put everything together in a little flow chart, statistically significant. That was the first thing we've talked about today. If results of a hypothesis test are statistically significant, then we have a low p-value because we're saying, you know what? It's unlikely to happen by random chance. And if we have a low p-value, do we support HA or do we not support HA? Well, we support HA. And when we support HA, we run the potential risk of making type 1 error. It doesn't mean we necessarily made error. A lot of times we're hoping we're correct, so no error was made. But we run the risk of potentially making type 1 error, since type 1 error is supporting HA when in fact HO is true. So now, if results are not statistically significant, that means we had a high p-value. Therefore, we do not support HA. And we run the risk of making type 2 error. So I think it would be good if you highlight this, because you could definitely use this tonight on your homework. I think it will be helpful and in studying for your test. Something else my students have pointed out in the past, they saw that whenever you have a low p-value, you run the risk of making the lower type of error. Whenever you have the high p-value, you run the risk of making the higher type of error. So you can add that in or take a look at that to help as well. Okay? Good luck on your homework tonight, guys.